2010 Canadian Open Mathematics Challenge, Part A. Determine the integer equal to this expression. Well, let's have a little bit of fun. 9 plus 5 is 14. 9 minus 5 is 4. And of course, you can do this manually, right? But I'm just going to factor it because I think it's a little bit faster. So this is 14, 14. This is 4, 4, plus minus, like that. And then the 9 times 5 stays the same. 14 plus 4 is 18. 14 minus 4 is 10. And then now you will see that 18 divided by 9, that part is 2. 10 divided by 5 is 2. So you just get 2 times 2, which is equal to 4. And like I said, you can do this manually without any kind of factoring also, but I just did it this way. Determine all values of x for which x minus 8 minus x is equal to 8 minus x minus 8. Okay, well, this one I'm just going to do straight without any factoring or strange tricks. So we have 8 minus 8 plus x. On this side, we have 8 minus x plus 8. Right? So bring everything to one side, and that becomes 2x plus x. This becomes 16 plus 8. 3x, therefore, is equal to 24. Divide through by 3, and x is equal to 8. In the diagram, each of the three circles has center O. Diameter CD of the large circle passes through points B, A, and O. The lengths of the radii of the circles are OA is 2, OB is 4, and OC is 6. What is the area of the shaded region? Well, the area we can just call 1, 2, and 3. 1 is just the semicircle, so pi r squared divided by 2. And r in that case is OA, which is 2. So this is pi times 2 squared over 2, and that is just 2 pi. The shaded area called number 2, that's a big semicircle, subtract a small semicircle. And that means OB is what, 4, right? Yeah. So this is 4 squared, and then this OA is 2, so this is pi 2 squared. So that's 8 pi minus 2 pi, so that is 6 pi. And then finally the third one, that's going to be the biggest semicircle, subtract the medium semicircle. So the big one is has a radius of 6, so that's pi times 6 squared over 2, minus the medium one, which is a radius of 4, so pi 4 squared over 2. So that's 36 over 2, 18 pi, minus 16 divided by 2, 8 pi, so that's 10 pi. So the total shaded regions are this 2 pi, this 6 pi, and this 10 pi, and that is 2 plus 6 plus 10 is 18 pi. So total is 18 pi for the shaded region. Determine the number of digits of the integer equal to. Okay, let's just look at the numbers, 3.1, 8, and 2, and then we'll put all the powers of 10 together. So 10 to the power 7, 10 to the power 8, 10 to the power 3. Okay, so this looks like 8 divided by 2 is 4, so 4 times 3.1, which is 12.4. And then this one, we're going to add them, so 10, 7 plus 8, and then we subtract 3, the basic exponent laws. So this is really 12.4. 7 plus 8 is 15, minus 3 is 12. So 10 to the power of 12. Okay, so that's it. Number of digits, well, you can just manually put this into a number. 1, 2, 4. Actually, let me make this a little bit different. Let me make it into a full number, 124. And because I multiplied that by 10, I got rid of a 10 from here, so it becomes 10 to the power 11. And now I can make it into one big long number. This 10 to the power 11 really is just 11 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the total number of digits of this whole thing, well, the 11 zeros plus these 3, so 11 plus 3 is 14 digits. And that's it. What point on the line with the equation y equals x is closest to the point p negative 3, 9? Okay, let's draw a basic diagram. It doesn't have to be a work of art. And y equals x is the line that goes right straight like that. So that is y is equal to x. Right, this is the x-axis, of course, and that's the y-axis. And then they want, what do they want? The closest to minus 3, 9. Okay, so minus 3, 9. If this is, say, minus 3, then approximately 9 is up here somewhere. So this is my point, minus 3, 9, and they're calling that P. And they want the point on the line that's closest to that. Well, the point on the line that's closest to it will be, the closest distance is a straight line that's perpendicular, like that. So they essentially want you to figure out this point right there. Okay, so how do we do that? Well, the first thing, of course, we're going to need to find the equation of that line. Since it is perpendicular to y equals x, its slope will be a negative reciprocal. So the line is going to have this equation as always. This line, the slope, it's 1x, right? So the slope of that line is 1. So the slope of this line will be the negative reciprocal of 1, which is negative 1. It's really 1 over 1, and then you add a negative. So this would be minus 1x plus b. And then that line has this point on it, so we can substitute that point in to get the value of b. So when y is 9, we have x equal to minus 3. So that means 9 is equal to 3 plus b, and therefore b is 6. So the equation of this line right here, this one, is y is equal to minus x plus 6. And therefore, we now have to find this point of intersection, which is the intersection of y equals x and y equals minus x plus 6. So set them equal to each other. We've got minus x plus 6 is equal to x. So 6 is 2x, x is 3. And we can substitute x equals 3 into there to get y is equal to 3. And therefore, this point right here is 3, 3. And that is what they wanted. That's the closest point to P on that line. On a calculus exam, the average of those who studied was 90%, and the average of those who did not study was 40%. If the average of the entire class was 85, what percentage of the class did not study? So the ones who studied, they had an average of 90%, and the ones who did not study had an average 40%. Okay. So the total number of students, we are not told anything, so I'll just call it X, number of students. They don't give us any such information. So I'll just represent X as the number of students that studied, and I'll call this Y, the number of students who did not study. All right, so this basically means that this 85 is represented as follows. You take all the students that studied, which is X, and multiply it by the 90. And then you add to that all the students that did not study and multiply by their average, which is 40. Then you divide by the total number of students, which is X plus Y. And this is a simple average. And that's how you get that 85. Basically, that's the mathematical equation you create entirely based on the information given in the question stem. Now you just cross multiply. So this is 90x plus 40y. This will be 85x plus 85y. And then this will be 5x, and this will be 45y. This means x is equal to 9y. So x is 9y. And then finally, we have to figure out what percentage of the class did not study. So the ones who did not study are represented by y, and the total number of students is x plus y. Well, x is 9y, so put that in. So this becomes y over 10y. The y's cancel, and you get left with 1 over 10. So 1 over 10 represents the fraction of the class that did not study. In terms of our percentage, that is, of course, 10%. In a diagram, rectangle ABCD has AB equal to 20 and BC equal to 10. Points W and K are outside of the rectangle with WA equal to KC equal to 12 and WB equal to KD equals 16. Determine the length of WK and express your answer in the form WK is equal to M times the square root of N, where M and N are positive integers and M is greater than 1. All right, so let's figure this out here. I think I'm going to draw a couple lines. So one that goes from W down perpendicular to AB like that, and another one that goes from K up perpendicular to CD like that. I think that should be sufficient. Okay, all right, let's move forward with this. So this was perpendicular, so these are basically right angles. That's a right angle, that's a right angle. And then let's label this. I think what I'm going to do is put everything on a coordinate grid. I think that will be very beneficial. And we have been given quite a few, pointers. So B, based on the question, is 2010. They've given you that information in the question. And this is 12, this is 16, this is 12, this is 16. And I think that's about it. Okay, well, the first thing I observed is that they told me that AB is 20, right? So that's 20. And so obviously DC is 20 also. And since 12 squared plus 16 squared is equal to 20 squared, that means that these are right angles right here. That's a right angle, and this is a right angle. So those are right triangles. All right, so now let's talk a little bit about trigonometry. Let's look at the sine of the angle WAB. So that WAB is right there. The sine opposite over hypotenuse is 16 over 20, which of course in lowest terms is 4 over 5. And also let's look at the cos of WAB. And the cos would be adjacent over hypotenuse, which is 12 over 20, which is 3 over 5. So this will be beneficial in figuring out this point right here in terms of a coordinate, because the sine of WAB, that angle, we can also look at it from the perspective of this little triangle right here, that one. Initially, we looked at it from the perspective of that big triangle, but if you look at it from the perspective of the small one, we can get the values for the coordinates of W. This point right here, I'll just call it X. So sine of WAB, if you look at the small triangle, will be the opposite, which is WX, over the hypotenuse, which is 12. Now, WAB's sine of it, we previously calculated as 4 over 5. So 4 over 5 is equal to WX over 12. And then when you solve for that, you get that WX is equal to 48 over 5. So that's very helpful, because that tells me that the distance from here to here is 48 over 5. And since the distance from here to here is 10, I just have to add 48 over 5 to 10 to get the y coordinate for W. So we got 48 over 5 plus 10, and when you add those up, you get 98 over 5. And that's the y coordinate of W. Now to get the x coordinate, we will start talking about cos. So the cos of WAB, again looking only at that small triangle, this guy, is adjacent, which is AX, over hypotenuse, which is 12. The cos of WAB we had previously calculated as 3 over 5. So 3 over 5 is equal to AX over 12, and therefore AX is equal to 36 over 5. So 36 over 5 is the x coordinate. So there you go. That's pretty helpful. And in a very similar way, I'll let you do K. Pretty much it's identical to the way I did W. You'll find that the coordinates for K are 64 over 5 and minus 48 over 5. Just follow the same steps I did using trigonometry on first this triangle and then on that triangle, and you'll be able to figure that out. So now we have the coordinates for W and the coordinates for K. To find the distance from W to K, you just use the distance formula. So the distance WK, it's going to be 36 over 5 minus 64 over 5 all squared plus 98 over 5 minus 48 over 5 all squared. And don't forget to take the square root. Okay, so this is 28 over 5 all squared, and this is 146 over 5 all squared. And this looks like 784 plus 21316 all over 25. And that is 22100 over 25. And that is, when you take the square root, you can take out 100, so that would be 10. And then you're just left with 221 under the radical sign, and 25 square root is just 5. So then that is 2 root 221. And that is your WK in the form m square root of n. And indeed, m and n are positive integers. Determine all values of x for which x squared plus 3x plus 2 times x squared minus 2x minus 1 times x squared minus 7x plus 12 plus 24 is 0. All right. Okay, so the first thing that comes to mind is that these are not really that similar, but if I can make them somehow similar, I can make a substitution. So let's see what I can do. Let's bring this here. The first one factors into x 2 1 plus plus. That's pretty straightforward. And the second one, I don't think that has a nice factor unless you use a quadratic. So I'll just leave that for now. This one, however, I know will factor nicely. X 3 4 negative. Yeah, and then we got this 24 out here. Now what I'm going to do is combine them. So, for example, this x plus 1, I'll combine it with this x minus 3. That's perfectly allowable since it's a product. I'll keep this in the middle, x squared minus 2x minus 1. And then this one, x plus 2, and this one, x minus 4, I'll stick out there. And then some very interesting things will happen. Now, when you expand this guy, you get x squared minus 2x minus 3. The middle one is the same, x squared minus 2x minus 1. And then this one becomes x squared minus 2x minus 8. Hopefully, you have noticed that we have arranged it in a way that they're all x squared minus 2x. So they're similar. So now we make this substitution. Let x squared minus 2x, I'll just call it a. So this now becomes a minus 3, a minus 1, a minus 8 plus 24 is equal to 0. And this is definitely something that we can work with. Expand it all and collect like terms. And when you do, you get a to the power of 3 minus 12a squared plus 35a a is equal to 0. And I can factor out an a, and that makes me get a squared minus 12a plus 35 is equal to 0. Okay. So that means I can factor this expression, I'm pretty confident, a 7 and 5. Yeah, 7 and 5, negative, negative. Okay, great. So that means a is either 0, 5, or 7. Now recall, a was that. So that really means that x squared minus 2x is equal to 0, or x squared minus 2x is equal to 5, or x squared minus 2x is equal to 7. So each of these, let's solve. So the first one, factor out the x, and you get x minus 2. So that means x is equal to 0 or 2. So that one's pretty straightforward. The next one, x squared minus 2x minus 5 is equal to 0. And this will involve a quadratic. I will let you do the quadratic. And when you do, you get x is equal to 1 plus or minus root 6. The last one, x squared minus 2x minus 7 is 0. Again, this is going to involve a quadratic. You can do that. And when you do, you will get x is equal to 1 plus or minus the square root of 8. And there you go. Those are the, looks like 6 values of x that satisfy this original equation.